Hi folks, welcome to another video. This is about solving polynomial equations. This is an extension of section 6.4 where we were factoring before, and now we're going to take the idea of factoring polynomials, and then we're actually going to go take the next step and solve them in terms of an equation. So the first one that we're going to do here is solve 3x to the fourth plus 3x cubed equals 6x squared plus 6x. So first of all, notice that we have more than one term with x, so I'm going to get all my terms on one side, and I'm going to write them in descending order. So I'm going to write 3x to the fourth plus 3x cubed minus 6x squared minus 6x equals 0. And now this is what we need to solve. So the first thing that we notice, hopefully, is that we have a common factor here. With all our terms, we can factor out a 3 in all these terms, and there's also an x, right? There's an x there, an x, and there's an x in there. So I'm going to factor both of those things out in my terms. Okay, so I'm going to pull out a 3x, and now I need to think, okay, 3x times what is going to give me 3x to the fourth? Well, that's going to be x cubed. And now 3x times what is going to give me 3x cubed? Well, that's going to be x squared. So I'm going to have plus x squared. And then my next term is going to be minus 2x. And then my next term is going to be minus 2. And all that, close parentheses, is going to equal 0. Now what I have so far, I can actually take a look at this 3x right here. So I don't need to keep writing this. I have this 3x times all of this. So that's really a product, right? That's really 3x times that whole factor there. So this factor here of 3x, I can set equal to 0, and I can get one solution right away. I know that x could be 0. So this is not something that you want to forget out here when you factor that out. If you bring out a variable, that's going to actually lead to one of your solutions. So I'm going to go ahead and do that. Okay, so now for the rest of this. Well, count the terms. We have 4 terms. So what kind of factoring is that going to be? So if you said grouping, you're absolutely right. Let's go ahead and group this, and we'll factor this and then solve it from there. So remember how grouping goes. We look at the first 2 terms, and we pull out a common factor. Well, we can pull out an x squared from those first 2 terms. And now I say x squared times what gives me x cubed? Well, that's going to be x. And now x squared times what gives me x squared? And that's going to be 1. So remember how this is supposed to work with grouping. Write this here in green. What's going to have to be left over here in order for us to be able to factor this correctly? Well, it's got to be exactly what we have here, right? We need an x plus 1. So I'm going to go ahead and write x plus 1 over here. I'll put my equals 0. And now I just need to figure out for myself, well, what do I need to pull out of negative 2x minus 2 so that I'm left with an x plus 1? Well, hopefully you said that you need to pull out a minus 2 out of that. Okay, so now our last step in grouping here. We have 2 big, what I've been calling mega factors here, or mega terms, right? We have that whole big x squared times x plus 1 and the 2 times x plus 1. They have a common x plus 1, don't they? You can see that they're in green. So I'm going to pull out the x plus 1, and then we're left with an x squared minus 2. And now I'm going to set that equal to 0. And now that we're really in familiar territory in that we have 2 factors being multiplied and we get equals 0, I can break these up. I can say x plus 1 equals 0, or x equals negative 1. That's my second solution. Remember we had x equals 0 over here. And for my other solutions, I can say x squared minus 2 equals 0. I can say x squared equals 2. And then I can take the square root of both sides. And I can say x equals plus or minus the square root of 2. And there I actually get 4 answers out of this. I get 0, negative 1, and positive square root of 2 and negative square root of 2. Okay, so let's look at another type of problem. Again, this is an equation that we're going to solve because it's set equal to something, 0 in this case. And I'm going to take a look at this, and I see something unusual here. We have these much larger exponents than we normally get, and there's nothing I can factor out of this, right? Because it's not like it's 9x or 9x squared out there. It's just a 9. But you should recognize this as quadratic form, and we've talked about this in class, where it has the same form as this, doesn't it? As a quadratic. So we'll think about how you would factor this quadratic. And we're really going to do the same thing, except instead of having x in my first two terms here, it's going to be, well, what is it going to be? Well, it's going to be half of x to the fourth, or it's going to be x squared and x squared. And now I just need to think, okay, well, what factors of negative 9 add up to negative 8? Well, that's going to be minus 9 and plus 1. And again, I'm going to set that equal to 0. So I've factored this, and we're going to take this one step farther, actually 2 steps past this, and actually solve this equation. So I can actually solve it from here. But what I'm going to do, just so that we see this factoring one more time, is this x squared minus 9 is actually the difference of 2 squares, x plus 3, x minus 3. And this x squared plus 1 is not the difference of 2 squares, so I'm going to leave that as is. And now I can go ahead and set each of these equal to 0. Again, we're kind of like in familiar territory, hopefully here. And we get x equals negative 3. For my second factor, I get x equals positive 3. And from my third factor, we can solve this. X squared plus 1 equals 0. I get x squared equals negative 1. And yes, we do know how to solve this because we have already dealt with complex numbers. But I'm actually going to end this right here because we're not going to actually have solutions with complex numbers. So I'm actually going to cross that off, at least for the time being. We'll see complex numbers a little bit again later on. But for right now, I'm going to say, well, let's just put this on the back burner. Okay, one more type of problem. We're going to look at an application problem. So the revenue R in thousands of dollars for small business can be modeled by this function here, R of t, where t is the number of years since 1990. So the question is, in what year did the revenue reach 90,000? Okay, so first of all, I'm going to notice that R is in thousands, and here's my revenue down here. So when I substitute in my value that I have there for $90,000, I'm not putting in 90,000. I'm just going to put in 90 because this is in terms of thousands of dollars. Okay, so this is my revenue, 90,000. So I'm going to put that in for R of t. And then write the rest of the function. And now notice we have 5 terms at this point, but we have a whole bunch of terms with t in it, right? So what I'm going to do is bring everything to one side. 0 equals, I'm going to have t cubed minus 8t squared plus t. And then we get what? Minus 8 out of that. Okay, so, well, how can we solve this? Well, we have 4 terms. 1, 2, 3, 4. So to me, that's screaming what? That's screaming grouping. So I'm going to go ahead and group these and solve it that way. And we've already seen a grouping today, but I'll go ahead and take this as slowly as we can here. Again, from the first 2 terms, we're going to factor something out of that. Well, there's definitely a t squared I can pull out. And I'm left with a t minus 8. So again, what it means over here is we need to have a t minus 8. Well, that's really what we have there. So, but we still need to write something out this way, right? So what can we pull out so that we're left with the same thing? Well, as it turns out, we want to pull out just a positive 1. That way nothing really changes when we distribute that positive 1 back in. Okay, so I'm going to go ahead and finish the grouping. And again, they have this common factor of t minus 8. So I'm actually going to pull out that t minus 8. And we're left with t squared plus 1. As it turns out, we actually just solved a problem like that where we had x squared plus 1, right? And this led to an imaginary solution. So I'm actually going to disregard that because I know how that's going to turn out. And I'm just going to solve this t minus 8. And that's actually not so hard to do, right? So I'm going to add 8 to both sides, and I get t equals 8. And now I'm going to go back up to the top, and I'm going to try to answer the question here. So the question is saying, in what year did the revenue reach 90,000? Well, if t is 8, and t is the number of years since 1980, I just need to add 8 to 1980, and I can say, excuse me, 1990. And that's going to tell me that we're going to reach this goal of $90,000 in revenue in the year 1998. So I hope you found this useful. Again, this is just some applications, some ways to solve some of these polynomial equations with factoring. We did some grouping. We did some, what was the other technique that we looked at here? We looked at quadratic form, and we solved some equations today. So again, I hope you found this useful, and I'll see you folks in class.